Yeah, good afternoon, everyone. Am I audible? Students? Students, am I audible? Yes, students, please respond. Am I audible to you? So I can start my session.
Yes, sir, you are
Yeah,
audible.
thank you, ma'am. Thank you. Yeah. Can you see my screen? Is my screen visible to you?
Yes, sir.
Yeah, thank you for your response. Yeah. So today we are here for the discussion on the topic of numerical relation and reasoning. Basically, we are dealing with this numerical relationship. We have learned in mathematics as well. We know line equation, that is y equals to mx plus c. So that equation represents what? Relationship, numerical relationship between y and x. Okay, now what is the reasoning behind this? If I ask you y y equals to mx plus c, then you can directly say that it's a line equation. Means there is a relationship between x and y, and that relationship is linear. So that would be your reasoning for this. Am I correct, students? See, students, I want interactive session, so please interact. So I will come to know you have understood something, because this topic is itself a ocean, because there are so many things involved in numerical reasoning and numerical relationship. So students, please give me response. Yeah, so we are learning this under the scheme of Prerna, myself, Dr. Prathamesh Potdar. Yeah, I'll proceed with the session. Now, what is reasoning? Reasoning is a process of thinking, because always for giving any reasons, we have to think from the person perspective. Based on that, you will give the reason. And what are the facts? That also we have to identify. Okay. So facts are premises about the something in logical way in order to form a conclusion or judgment. So while giving the reasoning, we are concluding something, right? And reasoning is based on the capacity of the person and based on the presence of mind, sense, its ability, knowledge. Okay, so these are the few factors which helps for reasoning. Okay, to rationally work through data and information. So it works through data and information. For example, if professor asks you to make a submission on particular date, and if you fail to submit that assignment, then you will start giving reasons, right? Those reasons would be based on your knowledge about that process, professor. Means how he is, on what reason he will accept. So that is your analysis of that particular person. That is your knowledge about that particular person. So based on that, you will start giving the reasons, and based on the reasons, reasoning will take place. The best example is, if there are clouds, dark clouds in the sky, you can predict there is a possibility of rain. So this is one kind of reasoning. But hello, if we develop the relationship between rainfall and some based between rainfall and some factors, then it is called as numerical relationship. Okay, so now we will going to deal with reasoning. See, both things are going hand in hand, reasoning and numerical relationship. So first of all, we're going to deal with reasoning and then we'll see. So these are few types of reasoning. The major classification is logical reasoning, verbal reasoning, non-verbal reasoning. In logical reasoning also, there are some few categories: a numerical number series, letter and symbols, making judgments, logical deduction. So these are the few categories under logical reasoning. Then verbal reasoning would be blood relationship. These are few categories. Okay, I'm talking about categories, cause and effect. Then logical sequence of what. Non-verbal reasoning, again, figure matrix, mirror and water images, pattern, completion, paper folding, paper cutting. So we're going to see few categories of each type. Okay, so first I'm going to start with logical reasoning. Now, what is logical? High quality reasoning, or there should be some base reference. Based on that, you will start developing your story, logic. Okay, that is called as logical reasoning. The best example is you might see in CID series, right? There is some logic. So based on logic, they are reasoning. What would be the would be the culprit or who would be the victim of that particular scenario? Okay. So logical reasoning skills can be learned and improved. So it's a iterative process. Logical reasoning is it's a iterative process, and you can improve and you can learn by observation, by reading, by taking knowledge. You can learn and you can improve. Logical reasoning questions evaluate the ability to analyze, evaluate, and complete arguments. So, this logical reasoning will help to build what analysis, then evaluation, why that thing happened. Okay, and then based on that, you will predict some conclusion. Yes, these are the findings or these are the outcomes of this study. Analysis, evaluation, and findings. Okay, now the best example for this is that is your exams. Analysis is what if let us take consider there is one subject called as strength of material. In the strength of material, there are 6 models, right? So student may prepare 5 models, 4 models based on the weightage. Right now, to conclude that, what he did some analysis based on the weightage. He have chosen particular model. Okay, to reduce the efforts. Okay, so after analysis, he have prepared, then he have attempted or he has given the exam. Okay, in examination, professor has evaluated him. Okay, now after evaluation, the conclusion is his result. So this is the process. Okay, next, the questions are based on the short arguments drawn from a wide variety of sources, including newspapers, magazines, advertisement, and information disclosure. So these are the few things which are involved in logical reasoning. Okay, now we'll go in detail. Go in detail for this. This is one category, number series. So there is some logic here in number series. So the first logic is arithmetic progression. You might heard this arithmetic progression, arithmetic series. These are the mathematical terms. Right now, for example, you consider there are numbers in in the given order 2, 5, 8, 11 up to n. Now, what is the common difference here? If you look at the common difference here is 3. Common difference is 3. 5 minus 2 is 3, 8 minus 5, 3, 11, so on. Right? If you look at second example, here 39, 15, 21, 27. Now, this is not in descending order. Randomly, they have given the numbers, but the difference between two numbers is 6. Common difference is 6. Okay, that is the beauty here. Then geometric progression or geometric series. For example, 3, 15, 75, 375. Now here in this case, the common ratio is 5. That is 15 by 3, 17, 75 by 50, 375 by 75. The common ratio is 5. Similarly, the another example is if you take the ratio 6 by 2 is 3, 18 by 6 is 3, 54 by 18 is 3. So what is our understanding here? In arithmetic progression, there we have to find out common difference. Means by what difference it is increasing. So we have to find out common difference in arithmetic progression. But in geometric progression, we have to find out ratio. Okay? This is the common factor for this series. Students, I hope you are getting something. Students, Kiran, please give me response. Make this interactive session. Otherwise, I am speaking and I don't know you are getting it, you are understanding or not. Pradeep, Pradnya, Naina, can you please respond? Akash, please give me response. You can write in chat box if you want. Okay.
Yes, sir.
So I am assuming that you have understood whatever I have discussed. You have understood. Next. So further in a number series, there is a possibility of combination of series. Okay, so this can be a series combining different rules in a logical way. Let us understand by example. Uh, the example is 9, 25, 49, 81, 121, and so on. This series can be represented by mathematical expression. Like by this expression, we can find out the another next number. Let us take where in this equation x is 1. Okay, if I put x is 1 here, so 2 plus 1 is 3. It's raised to 2. Okay, it is on the top. It's a degree. It's not a multiplication raised to 2. So 2 plus 1 is 3. 3 raised to 2 is 9. Let us go for next number. If I substitute 2 here in this equation, 2 plus 2 into 2 is 4. 4 plus 1 is 5. 5 raised to 2 is 25. So like that. So if I ask you to calculate the 10th number in this series, right? So you will going to put x as a 10. 10 into 2, 20, 20 plus 1, 21, 21 raised to 2. So that would be the number on 10th position in this series. Okay. So this is a series of perfect squares. Here we have a perfect square. But the expression is like this. Then the B category is series of perfect cubes. So for this, the expression would be f of x is equals to 27 into x minus 1. Okay. Suppose x is 0. F of x would be 1. Like that. Similarly, the another series is 164, 373,000. So by this expression, so what is our understanding is we have to find out the equation, hidden equation based on the given series. Okay. So these are few examples comes under numerical series. Then under numerical series again there is a second degree of arithmetic series. Here, a series in which the differences between the successive terms themselves are in arithmetic progression and forms an arithmetic series is called a second degree arithmetic series. For example, here 2, 3, 6, 11, 18. This series is given. The difference between the successive terms themselves are in arithmetic progression. So Here, if you take the difference, 3 minus 2, the difference is 1. 6 minus 3 is difference is 3. Then 11 minus 6 is difference is 5. So on. Which forms an arithmetic series. Okay. So this is the difference is in series. See, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 9. Like that. Okay. So, or you can say that difference is 2. The given series can be represented by quadratic mathematical function by this equation. So f of x is equals to x raised to 2 plus 2, x raised to 2 plus 2. If x is 0, we'll get this 2. If x is 1, we'll get 3. So this is the mathematical form for the given series. But what is there? It's a combination of these two. Combination of this series as well as this mathematical form. If x is equals to 3, 3 raised to 2, 9, 9 plus 2 is 11 when x equals to 3. Okay? Then, so here we have discussed second degree arithmetic series. Second means there is a combination. Third degree, third degree means in that equation x we will have x raised to 3. That is a third degree. Again, for this, what is our objective? We have to find out difference first. The difference of successive term of the above series is this. So, what is third degree arithmetic? A series in which the difference of successive term forms a second degree arithmetic series. It's termed third degree arithmetic series. Mathematically, such series can be represented by general cubic function. So, in this is represented by generic cubic function. That is 2x raised to cube minus 2. This is the mathematical form for this equation. Okay, I'm going a little bit fast because we are on logical reasoning. Like that, there are two more categories. In logical reasoning, there are so many things. Number series, again, number series, arithmetic to geometric series, arithmetic to geometric. This series is formed by combination of arithmetic progression. Each succeeding term is obtained by first adding or subtracting the common difference of its arithmetic progression to the previous term and then multiplying. So first adding or subtraction and then multiplication. The sum by common ratio of it is called as geometric progression. And the important property of such an arithmetic geometric series is that the difference of successive term in GP. So let us consider one example. Suppose this series is given 1, 8, 22, 55, 50, 106. So this series is obtained by adding 3 to previous term and then multiplying by 2. See, 1 plus 3 is 4, 4 multiplied by 2 is 8. Let us go for next. 8 plus 3, 11 multiplied by 2, 22. 22 plus 3 multiplied by 2, 50. So there is an addition and then multiplication. So that this type of series comes under arithmetic geometric series. Then there is another category that is geometric arithmetic series. So here first we'll multiply or divide and then we'll go for adding or subtraction. Okay, so let us consider this example 1, 2, 6, 22. So the term in the above series are obtained by first multiplying the previous term by 4 and then subtracting 2 from the resultant product. Let us consider 4 into 1 is 4 minus 2 it's 2. Okay, then 4 into 2 8, 8 minus 2 6, 6 into 4 24, 24 minus 2 22. So like that, first multiplication and then subtraction here. Then in number series, twin series means if there is a combination of two things, single series, and an alternative term, this series from the independent series. Let us consider, we'll understand by example 2, 3, 7, 9, 12. This is the given series. Okay, odd terms of this series are 2, 7, 12, 17. Okay, and arithmetic series with common difference is 5. Now, if you look at the difference, 7 minus 2, 5. 12 minus 7, 5. Right? 17 minus 12, 5. 22 minus 17, 5. So there is a common difference. Okay? This is for what? Odd series. Even terms of the series are 3, 9, 27, 81, and so on. So is a geometric series with a common ratio of 3. 9 divided by 3 is 3, 27 divided by 9, 3. So there is a common ratio of 3. Now, this is another category of logical reasoning only. Letters and symbols in series. Right? In GATE examination, we will receive this kind of questions as well. When the letters and symbols in series. Okay, so alphabets in series. In such a series of alphabets is given and which follows a pattern. So we have to identify that pattern based on. So to identify that pattern, we have to develop some logic. Okay, so therefore you have to decipher the pattern and complete the series by choosing the correct alternative given in the question. So first of all, we have to develop the logic. What logic is there? We have to crack that logic, and based on that logic, we have to find out the correct answer in this letter and symbol series. So there are few rules for the alphabet series. So the first rule is keep the order of the letters with their respective numbers. That is A equals to 1 and Z equals to 26. Vice versa also we can write. So this is the rule number 1. When counting is circular, counting is circular, after Z the cycle will continue from A. Circular means we have to place, means there is a closed loop here. Okay, then in that case, the cycle will continue from A again, new cycle. Okay, so one cycle is completed, second cycle is completed. Again, third cycle will start from A. Sometimes letters are permitted in sequence. Example A, B, C, E, F, G. Here D and H is in the sequence are omitted. Sometimes equal number of letters are omitted. Example ADG. ADG. In this case, equal number of letters are omitted. CD is BC is omitted here. EF is omitted here. So this is again one pattern. We have to recognize that pattern. One following, one following the letter and the other proceeding, it may be organized in this way: BCA. C follows B and A. And A predecedes B. So this is the combination. What is this? C follows B and A predecedes B. Okay. So this is another rule. Sometimes there may be a repetition of letters in state of order. Example: AAB, ABC. One letter is repeated twice, and next set could be CCD. So these are few examples. Sometimes number are mixed with the letters, and the number may refers to the position of the letter in the alphabet. So we are going to understand all these rules by example. Let us consider first example: ABXW, then EFTS. Third is missing for us. There is another combination MNLK, and we have four options. A is IJOP, B is IJPO, JIOP, and D is JIPO. So if you look at this, yes, if you look at this, AB, AB, EF, MN, what is there here? First and second terms are in order. Third, fourth terms are in reverse order. Terms instead they have written KL, logic, we found solution as B. See, AB, CD is missing, EF, IJ should be there because we have this IJ. We will not, IJ, JP is not possible because it's in reverse order. Again, this is in reverse order. So IJ is possible, right? And OP is a forward sequence, but here they have used reverse logic. So PO. So the possible solution is B. Yeah, students, am I audible to you? Abhijit, Pradeep, can you hear me?
Yes, sir. Yes, sir.
Yeah, I extremely sorry because of network issue. I was disconnected. Okay. Can you see my screen?
Yes, sir. It's visible.
Yeah. We were discussing about this letters and symbol in series. Okay. So for that, we have discussed these rules. I hope you was there for this rules and alphabet series, right? So we're going to understand by example all these rules. Let us consider there is a combination AB, XW, comma EF, TS. We don't know this series in between series, and there is another. Next is MN, LK. Right? In this series, we have to find out this unknown. Okay. So if you look at first two letters, AB are in series. EF, that is also in series. MN is also in series. Okay, or in order. But if you look at another two alphabets, those are in reverse order. Instead of WX, what we have XW. Instead of ST, we have TS. Similarly, instead of KL, we have LK. Okay, so if you look at the alternatives, okay, first two letters should be in proper order. So IJ and IJ, these two options is possible. Out of four options, we have eliminated these two options because first two letters are in reverse order, which is not applicable as per our logic. Yes or no? Okay, so A or B option is possible. But if you look at another two terms, another two letters, XW, these are in reverse order. So we will not have OP. Instead of OP, we'll have PO. So this represents what? Reverse order for last two letters. So by this logic, we can select our alternative as a B. Okay, our answer is B for this scenario. So the missing term would be IJPO. Now let us consider another example. XBVTCR. Now what logic is involved here that we're going to see. If you look at first letter, third letter, fifth, sorry, not third, fourth letter. If you look at first, fourth, and seventh letter, those are in order A, B, C. All these are in order A, B, C. Okay, and what is the mathematics involved here? 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. So 10th order should be D. Okay, later should be D here. Okay, now if you look at our options, first option is EO, second option is OQ, third option is FO, and fourth option is PD. Okay, so in that scenario, only one option is correct in our case, that is fourth, because as per our logical reasoning, 10th letter should be D. Okay, now we are interested in ninth letter. Okay, so ninth letter would be second and third letters are in reverse. Second and third letters are in reverse. So instead of XZ, ZX. Similarly, TV we have written VT. So here we will have instead of PR we'll have RP and then D. So our solution is PD here. That is D. So, okay, so we have given the reasons and we have identified what relationship is involved. Okay. Now this is another category. We are dealing with logical reasoning only. Logical deduction premises versus various patterns. So type 1, if A happens, B will happen. If A happens, B happens. Okay. So A is the predecessor of B in this case. This means that A leads B, but does not mean that the reverse. Means it doesn't mean that it is also applicable in reverse way. If B happens, A is happening. That is, if has happened, A must have happened. That is the reverse way. In such a situation, A is sufficient condition, means A is a mandatory condition here for B, but in it is not necessary condition. Let us look at the following example. We'll understand this by example. If I go to movie, I enjoy myself. What is the example? If I go to movie, I enjoy myself. This would mean that if I have gone to the movie, I will definitely enjoy myself, right? But it doesn't mean that if I have enjoyed myself, I must have go to movie. Yes, absolutely not. Means if I enjoyed, there may be another reason for enjoyment. This is one possibility here. If I am going for movie, then I will enjoy myself. Yes or no? Another example of this type would be if Amitabh acts in a movie, he will earn money. But it doesn't mean that he has earned money by movie itself. By making movie, he has earned the money. No, it doesn't mean that. He may have different resources for earning money. Yes or no? So this is type 1. If A happens, B happens. Second type is only if A happens, B happens. In this case, A is necessary and sufficient condition for occurrence of B. Means A has to perform. Only if A happens, B happens. There is a reversibility of logic, that is, if B has happened, means what? A must happen. Let us understand this by example. If Saurabh plays the match, will he get 100? Other way around, if Saurabh has got 100, he must have played the match. Right? Second statement is more meaningful. Means if Saurav has got 100, means what? He has played that match. Right? Third time, if A happens, B does not happen. In this case, if A has happened, B does not happen. The possible is also true. That is, if B has happened, A must not have happened. Means there is no relationship. Okay. If Martina plays well, Sania will not win. There is no relationship between A and B. This is a type 3. Type 4. If A does not happen, B will happen. Means again in this case, the reverse might not be true. If Anand does not come, Kasparov will win. This does not mean that Kasparov comes and Anand will not come. So there is a dicey situation here, or there is some ambiguity in the statement itself. So we have to understand that. And the last category is either A or B will happen. One of the two has one of the two has to happen at the same time. The two events are executive of one another. If one happens, the other will not happen. Either he become a TV star or he becomes a movie star. Okay. Students, are you with me? Supriya, Abhijit, Pradeep, Akash, Swati. I hope you are getting something. Now we'll understand by one example. Shahrukh either acts a villain or he acts as a hero. Try to understand this. Shahrukh either acts as a hero or he acts as a hero. A villain or acts as a hero. So, in that case, Shahrukh acts like a hero. This is the first alternative. Shahrukh does not act like a villain. Shahrukh act like a villain. Shahrukh does not act like a hero. So, what is the possibility? Shahrukh will act as a hero or Shahrukh will act as a villain. Right? If we are considering Shahrukh is acting as a hero, then look at A statement. Shahrukh acts like a hero. So A statement is valid. Look at B. Shahrukh does not act like a villain. Indirectly, if it is not acting, does not act like a villain, means he is acting as a hero. Right? So A and B, only A and B. So we can select B solution. Right? But if you look at C, he may act as a villain. Either we have written Shahrukh either act as a villain or act as a hero. So let us consider he is acting as a villain now. So Shahrukh acts like a villain or Shahrukh does not act like a hero. So we can have A alternative also. But if you look at C option, which shows CD and BA, means we can consider all these four alternative here in our case in logical deduction premises versus pattern. Let us consider second example. Whenever Martin goes to a movie, he has nightmares. Okay, so Martin did not have nightmares. First thing, try to understand statement. Whenever Martin goes to a movie, he has a nightmare. So first conclusion may be Martin did not have nightmares. Martin went to a movie. Martin had nightmares. Martin did not go to the movie. So these are the possible cases. So here, what is our understanding is when A happens, there is a possibility of B happens. Right? If A does not happen, it is not necessary that B will not happen. That is also possibility. Means if Martin is not going to the movie, still he may have nightmares because there is no relationship. Okay. Also, if B has happened, it is not necessary that A must have happened. So that is also possibility. We are talking about possibility here. Okay. However, if B has not happened, it is not. It is necessary that A must not have happened. So thus, our option is AD. AD is what? Martin did not have nightmares and Martin did not go to the movie. So that is the correct option here, AD in our case. Okay, I shall go ahead. Now here, theme detection. We have to understand theme here. This is also in logical reasoning. We are talking about logical reasoning only. Let us understand this theme detection by example. Since it is possible that substances contain tree roots may provide a cure for AIDS, the government must provide sufficient fund to allow through testing of this possibility. Means this is one hypothesis. Substance contained in content tree roots may provide a cure for AIDS. Means there is some substance contained in the tree roots that will help to cure AIDS. So what is our claim? The government must provide sufficient fund. So the argument of above assume that substances contained in the certain tree roots will probably cure AIDS. This is first statement. The line of research mentioned offers at present the most promising possibility for finding cure for AIDS. The possibility of finding a cure is sufficient reason for funding reason in possible AIDS cure. A cure for AIDS would be extremely valuable to the society, and the government is only possible source of fund for the research described. Okay, if you look at E statement, the government is only possible source of fund for research described. This is invalid reason because there are other bodies, agencies, which provides fund for research. So E is invalid. Okay. If you look at D, a cure for AIDS would be extremely valuable to the society. Yes, but it doesn't talks about our theme. We are applying for funding, right? This is the outcome. Our society want this, but it is not related to our theme. If you look at A, substances containing certain tree roots will probably cure AIDS. Again, we have not proven this. We are just we are just saying probability. We are not sure. Again, here we are not talking about we need a funding for this. Okay. B. The line of research mentions offered at present the most promising possibility for finding cures for AIDS. Not appealing. The possibility of finding a cure is sufficient reason for funding research into possible AIDS cure. So the correct answer is this. C. The possibility of finding a cure means there is a possibility we can find out the solution or we can cure the AIDS, and that is the sufficient reason for funding this research. So this is the appealing reason for funding that project. That is the possibility of finding a cure. Okay, so these statements talks about what our problem statement. So this is our theme. Okay, so this comes under theme detection. Let us take another example. Statement: each honest man is awarded a medal. Conclusion: Ram should be awarded a medal. Second conclusion: Ram should not be awarded a medal because he is not honest. Try to understand statement one. Statement: each honest man is awarded a medal. Okay. What are the two conclusions? Ram should be awarded a medal. What does it mean? We can say that Ram is honest, right? But second alternate conclusion is Ram should not be awarded a medal because he is not honest. Okay, we have options. Only conclusion one is correct. Only conclusion two is correct. Neither conclusion one nor conclusion two is correct, and both the conclusions are correct. Conclusion 1 is not correct. There is no discussion of the main fact of the statement in it. Because Ram should be awarded a medal. But why? Why he has to award it as a medal? That reason is not given in the first conclusion. Ram should be awarded as a medal, but for what reason? That is not mentioned. Conclusion 2 is correct because it is clearly stated that Ram should not be given the medal because he is not honest. So there is a reasoning here. Okay. So our solution is B. We'll go to next. Now this is another category. So we have discussed few aspects of logical reasoning. Now we are discussing about verbal reasoning. Verbal reasoning questions are designed to identify the ability of the candidate to understand and respond to question about information provided in the question passage and to determine whether specific conclusion can be drawn from the information presented or not. Okay, so the examples in verbal reasoning is blood relationship. Family or blood relationship means persons connected by relationship like father and mother, son, daughter, brother, sister, grandfather, grandmother, uncle, auntie, like that. So many. Okay, so we're going to see few categories of verbal reasoning. So the first category of verbal reasoning is blood relationship. Okay, so in blood relationship, there are examples father, mother, son, daughter, brother, sister, grandfather, grandmother, uncle, auntie, nephew, niece, brother-in-law, sister-in-law, and many more. Okay, now what is this? This is a common relationship. Grandfather's or grandmother's only son means what is the relationship? Father. So grandfathers and grandmothers only daughter-in-law, mother. So this summary is very, very, very important. Father's father or mother, grandfather. Father's mother or mother's grandmother. Father's brother or mother, uncle, sister, auntie, son's wife, daughter-in-law. So this table is very important to solve this kind of uh, questions. Okay, in GATE examination. Now, type 1, mix up relationship description. Concept and insight. Mix up relationship. The candidate is required to decipher the whole claim of relationship and identify the direct actual relationship between the concerned person. So the example is pointing to a gentleman, Dinesh said, he is only brother, is the first of my daughter's father. How is the gentleman related to Dinesh? What is this example? Pointing to a gentleman, and that gentleman name is Dinesh said, his only brother is the father of my daughter's father. So what is the answer here? The answer is uncle. Why? The gentleman only brother is the father of Dinesh, as Dinesh daughter's father is Dinesh himself. Gentleman is a brother of Dinesh father. That gentleman is the brother of Dinesh father. So that the relationship is uncle here. Simple example to understand. Next, blood relation. Again, this is a mix-up relationship. Pointing to pointing to Ajay, Radha said, his father is the only son of my grandfather. Try to understand this. Pointing to Ajay, Radha said, his father is the only son of my grandfather. So how is the related to the Ajay? Okay, so we'll understand by this figure. There is Ajay and Radha. Okay, so when the Radha's grandfather, only son is the Ajay's father, then the Ajay's father is also the father of Radha. So Radha is Ajay's sister. Hence, answer 2 is sister. So Radha is Ajay's sister. Okay, so our solution is here sister. I'm repeating, pointing to Ajay. Radha said, his father is only son of my grandfather. Okay, means the relationship between Radha and Ajay is of sister. Lalita said to Tina, you are the daughter in law of the grandmother of my father's only son. How is Lalita related to Tina? Okay, so we'll understand solution. My father's only son is my brother. Tina is a daughter-in-law of grandmother of Lalita's brother. Tina thus can be their mother or wife of grandmother's only son. However, so in that case, the solution is too confusing and we cannot. So indeterminable relationship here. That is the solution. Next, introducing Nita, Anil said, she is wife of my mother's only son. She is the wife of my mother's only son. How is Nita related to Anil? So, Nita is a wife. What is Nita is a wife of Anil's mother's only son. So, who is himself? Who is Anil himself? Hence, answer is Anil's wife. Means Anil is the son of this mother and Nita is his wife. We'll move ahead now. These are few tricks, syllogism tricks. Oh, solving methods for syllogism. Syllogism can be solved in many ways. However, the most frequent used method is by using Venn diagram. Okay. So Venn diagram shows all possible and hypothetical logical relationship between collections of finite and infinite segments. So let us take one example. All candidates are right-handed. All Canadians are right-handed. Second, all right-handeds are opticians. So based on these two, conclusion is some opticians are Canadian. Okay. What is our theme? All Canadians are right-handed. All right-handeds are opticians. And the conclusion based on these two, some opticians are Canadian. To check the validity of this statement, first we have to find out subject. Subject is optician. Predicted Canadian. And middle term is right-handed. Okay, so in this case, we have satisfied two premises from the example, that is optician and Canadian. So the conclusion must be valid since it is not possible for the premises to be true and the conclusion is to be false. So here, what is our understanding? Some opticians are Canadian. So this statement is false here, not necessary. Some opticians are Canadian. See, try to understand this. All Canadians are right-handed. Then all right-handeds are opticians. So based on these two statements, we have derived some conclusion. That is, some opticians are Canadian. Okay. Now to validate this, we have found out three things: subject, predict, and middle term. So the subject is optician, predicate is Canadian, and middle term is right-handed. So we are satisfying A and D. So that conclusion must be valid for subject and predicate. But it is not possible for all three. Okay? Now, condition. So after this, we will stop here. Conditional syllogism. Conditional syllogisms are better known as hypothetical syllogisms because the arguments used here are not always valid. The basic of this syllogism type is if A is true, and then B is true as well. Example, if John is eating sweets every day, he is placing himself at a risk for diabetes. So the minor premise, premise is Johnny does not eat sweets every day. Conclusion. Therefore, Johnny is not placing himself at a risk for diabetes. But the thing may be different. This conclusion is invalid because it is possible that Johnny does not eat sweet every day, but he may eat cakes every day. That is a possibility here. He may eat cakes every day or other things what also put him at a risk for diabetic. Okay. So here we'll stop. Yes. Students, if you have any doubt, please let me know. Otherwise, we'll stop our session. Pradeep, Swati, Abhijit.
No, sir, no doubt.
So, shall we stop for today's session? It's already 1:06.
Yes, sir.
Yeah. Thank you.